Welcome to this session on statistics. Today, we are going to analyze a specific scenario regarding class performance and explore the concept of the median from first principles. Our goals for today are as follows. First, to understand the definition and derivation of the median. Second, to compare the median and mean as measures of central tendency. And finally, to apply these concepts to a real-world dataset. By the end of this video, you will be able to determine the median of a dataset and justify why it is a robust measure of typical performance when dealing with outliers. Let's start by looking at the problem provided. A teacher is reviewing test scores for 7 students. The recorded scores are 45, 60, 55, 70, 65, 50, and 75. Our goal is to find the typical performance of this group. The teacher wants to understand how the class did as a whole, but specifically wants a measure that isn't overly influenced by extremely high or low scores. In statistics, we call these types of indicators measures of central tendency. They help us find the center of a data distribution. Our first task is to arrange these scores and determine the median. But before we calculate, let's derive what the median actually is from first principles. From the first principles of statistics, the median is the value separating the higher half from the lower half of a data sample. What exactly is a median? From the first principles of statistics, the median is defined as the middle value of a sorted dataset. It is the point that divides the distribution into 2 equal halves. To find the exact position of the median, we use the formula n plus 1 divided by 2, where n represents the number of data points in our set. When n is an odd number, like in our case with 7 students, this formula gives us a whole number, pointing directly to a specific value in the ordered list. If n were even, the formula would result in a 0.5 value, meaning we would take the average of the 2 middle numbers. The fundamental principle of the median is its resistance. Unlike the mean, which sums all values, the median only cares about the order. This makes it a robust measure, meaning it won't be dragged away from the center by 1 or 2 extreme scores. Now, let's apply this to the teacher's data. To find the median, we must first rank the scores from lowest to highest. This is a crucial step. The median cannot be found from an unordered list. Here are the raw scores. Let's reorder them. We have 45, then 50, 55, 60, 65, 70, and finally 75. Since there are 7 scores, our position formula tells us the median is the 4th value in our sorted list. Counting down, 1, 2, 3, 4. The 4th value is 60. So, the median score for this class is 60. This completes our first task. Moving on to task 2, we need to explain what this median of 60 actually represents in this context. In our classroom scenario, the median is the middle performance. This means that exactly half of the students scored a 60 or higher, while the other half scored a 60 or lower. It represents a typical score because it sits right in the heart of the distribution. If you were to pick a student at random, the median tells you what the center of the class looks like without the result being skewed by one person who studied all night or one person who didn't study at all. As you can see on the screen, 60 acts as the balance point for the number of students, effectively splitting the class into 2 equal groups based on their achievement. Now for task 3. Let's discuss why the median is often a better measure than the mean for describing student performance in situations like this. To see this clearly, let's calculate the mean of our dataset. The sum of 45, 50, 55, 60, 65, 70, and 75 divided by 7 equals 420 divided by 7, which is 60. In this specific case, the mean is also 60. But imagine if one student had a very extreme score. Suppose one student scores 10 instead of 45. The new mean would be 10 plus 50 plus 55 plus 60 plus 65 plus 75, all divided by 7, which is approximately 55. Notice how the mean dropped significantly because of one low score. However, look at the median. With the new ordered data, 10, 50, 55, 60, 65, 70, 75. The middle value is still 60. The median stays at 60. This is because the median is based on the position of the values, not their magnitude. Why use the median? First, it is resistant to outliers. Second, it is better for skewed data. And third, it represents the typical experience. The teacher's goal was to avoid being influenced by extremely high or low scores. The median fulfills this perfectly because it ignores the actual value of the extremes and focuses on the middle of the pack. It provides a more stable reflection of the class's general ability when the data isn't perfectly symmetrical. Finally, for Task 4, we must advise the teacher on the general level of performance based on our findings. With a median of 60, we can inform the teacher that the typical student is performing at a level of 60%. Looking at the data, the scores are spread relatively evenly around this center point, ranging from 45 to 75. A median of 60 suggests a moderate level of performance across the class. It indicates that, while the class has a solid foundation, there is significant room for improvement to move that middle value toward a higher grade bracket. The teacher can use this median as a benchmark. To improve the typical performance, the focus should be on shifting the entire distribution upward. We have successfully analyzed the scores, derived our formulas, and provided a statistical interpretation for the teacher. You now have a deeper understanding of how the median serves as a reliable anchor for data analysis.